Ready to make a spoil board for your 4040 XE machine? Then stick around because that's what we're doing today. Hey everyone, and welcome to another episode of James Dean Designs. If you're new to the channel and love CNC, make sure you hit that subscribe button in the corner to get all the latest videos. Now in today's episode we're going to be making a spoil board for the FoxAlien 4040 XE machine. Now a spoil board is an essential part of a CNC setup because it saves you causing any damage when you're cutting through material. It's also one of the best ways to make sure that we can get a level bed so that everything cuts nice and even. Now some of you may be thinking, well, isn't the bed on the FoxAlien machine already an MDF, so therefore a spoil board? Well, technically no, it's an MDF bed, not a spoil board. The difference really is because it's got all the metal inserts through for the clamps, you do run the risk of ruining bits if you cut too deep into that. So what we're going to do today is produce a spoil board which just ensures that anytime we cut through material we're going to have that bit of extra buffer to stop damaging any of the bits. So let's start by taking a look at what we need to produce this spoil board. So throughout the video I'll be referencing various files or bits. All of them can be found in the description area below the video. Check it out, there's lots of useful information in there. So we obviously need a piece of MDF to start with, but we actually need two pieces. Now the reason for this is if we cut straight through this onto the existing bed, when we put all the holes in for the clamps, it would leave marks in the bed below it, and that's something we're trying to avoid. So what we do is we cut two pieces together. Now as it cuts through the top layer, it will go into the piece below it and therefore not damaging the bed. We then flip it over, do exactly the same again, and it just minimises making any mess on the existing bed. We also end up with two spoil boards, so once the first one has been used and destroyed after a fair bit of wear, we've got a fresh one to put back on top a couple of months down the line. Now the MDF that we're using today is 6mm thick, and it is cut to a length of 400 by 400mm, so a nice square piece. Now the reason we're doing it to the exact cutting area of the machine is because if we go any bigger, when we surface it later, which is basically taking a top layer off the whole piece, if the MDF was any bigger, we'd end up with a little bit of a pocket all the way around the edge and basically a little lip going around. Now if we try to put a piece of material on top that is bigger than the 400 cutting area, it would essentially sit at a slight angle because it would be resting on that lip. And that's the reason that we're doing the spoil board at 400mm by 400mm as opposed to going bigger and aligning it with the bigger piece of MDF that is already on the bed. Now the bits that we'll be using today, we'll be starting with a 1/8 flat end mill or a 3.175 flat end mill. We're going to be using this to cut out all of the holes for the clamps and the various bolts along the front. Next we'll be surfacing the bed, and to do that we need a surfacing bit. This is a 20mm surfacing bit, also known as a bottom cleaning bit. Now the code that we'll be using today can accommodate from 20mm up to 25mm or 1 inch wide. So it depends on what you're able to source, but as always I'll put links in the description below for all the parts we're using. Now the surfacing bits have a bigger shaft, and basically what that means is if I turn these two around you should just be able to see the difference. We have a 1/8 versus a 1/4. Because of the width of the bit, it needs the extra strength in the shaft, otherwise it would break pretty easily or flex. Now in order to accommodate this 1/4 inch shaft, you will need a 1/4 inch collet insert to go into your ER11 collet. Again, as I say, I will put links to all these in the description area below. After that we'll be putting an alignment grid on the board itself. This will just be a series of lines going forward and backwards, left and right, which will make it easier to align projects in the future. And to do that we'll be using a V-bit. Now the one I've got today is a 20° V-bit. It doesn't matter if it's a 20, 30 or even a 10° V-bit, as long as it's obviously sharp enough to do that engraving, because it will just be quite shallow. Now after we've done all that, the final stage we'll be looking at later in the video is tramming. Tramming is basically where we're getting the spindle perpendicular to the bed itself, and in order to do that we'll need some sort of tramming jig. Now this is just one that I 3D printed, and there'll be a link to the file below. However, if you don't have a 3D printer, I will be showing you an alternative method using two Allen keys, so don't worry if you don't have access to anything like this. The next thing we need to do on both pieces of MDF is put a mark exactly halfway along. So as this is 400mm, the mark will need to be at 200mm. So make sure you're using a sharp pencil and come in, measure it up. We'll want to make sure that the mark is on both the top and the front of the board. So I'm just going to make a little mark there at 200mm. I'll do the same on the one below. And then I'll come in with a square shortly just to mark this up square along the front edge of both boards. So as we can see, I've just marked up the front of those both at 200mm. This will be to align it to the centre of the bed when we take it over to the 4040 XC CNC machine. So the next step is to stick the two pieces of MDF together so that they hold when everything is being machined. Now to do that we're going to be using blue tape and CA glue. We're going to be using Starbond today because it is a brilliant adhesive and it holds things together very well. If you check out the description area you will find an exclusive link to Starbond where you can get 10% off. So now I'll show you how we stick these two boards together. So what I've done is lay each board next to each other and made sure that they are perfectly aligned with each other. We're then going to take the glue from the Starbond and apply that to one half. We'll then apply the accelerator to the other half, sandwich them together, apply a little bit of pressure and make sure they stick really well together, and that will be this stage completed. And so the boards are now held together nice and tight and they shouldn't move when we start machining them. So we're about to fix the spoil boards down to the bed, but we need to make sure that it is perfectly central to the middle of the bed. So what we need to do is bring in a ruler and measure 225mm across. The width of the bed is 450mm, so we're aiming for the middle of that. Now it's roughly given by the position of this bolt, but we still need to make sure we get it exact. The more precise you can be with your measurements, the better aligned everything will be later. We also need to make sure we just mark slightly down the front of that as well, again to align with the pencil marks. You can then pull your spoil boards forward and align it with the pencil mark and make sure the gaps at either side are equal so that we know this is central. I would also suggest using a pencil just to make some marks on either side, because we'll need to flip this over shortly, so it will just make it easier to align and again make sure that it remains central. So we're now using the exact same method again. We're going to use the blue tape and the glue to hold the MDF spoil boards down to the bed. We're going to put glue on the base, the activator on the spoil boards, and then stick them down, again making sure everything is centrally aligned to the main bed. So with the boards now held firmly in place, install your 1/8 flat end mill and also position the bit to be right over the top of the corner of the boards themselves. Now what I strongly suggest doing at this point before we start machining anything is make sure your machine can actually cut the parameters that we need for this. It should in theory cut 400 by 400, but depending on where your limit stops are, it may not quite touch that. So set it up in the bottom left hand corner. It doesn't matter whether you're using the PC or the offline controller, but send it 400mm in every direction to make sure that it does cover the entire area. If for any reason it triggers a limit switch, you may just need to readjust those limit switches to make sure you can cover the full 400mm. Perfect, so now I know when we're running the programs there shouldn't be any issues with it hitting the limit switches. So we've double checked that the machine can run in the full parameters that we need it to. The next thing we're going to do is load in the job and get the holes cut. So we're in UGS today. Obviously you can use your offline controller or another program. This is just my preferred method. So the first thing we're going to do is come up and make sure the machine connects. We've got the usual alarm code, which is good news, so we can click unlock and everything should now be released. Now I've already positioned my bit directly over the corner and got the Z height correct. Obviously you can do this with a Z probe, with a piece of paper, whatever is your preferred method, as long as the bit is just about touching the top of the material. Now as mine's already done, the first thing I'm going to do is click reset 0 in order to set it. Then I'm going to come to the open folder, head over to my desktop, and I'm going to load in the first program that we're going to run, which is holes. As we can see from the visualization on screen, it's going to machine all of the various holes for the clamps. It's also going to machine the 3 holes along the front for where the bolts go, just in case we ever need to take the bed off. And we can see that everything looks as it should. We know the Z has been set, so let's get this job started. So with the first pass done, we're going to prise this off the bed. Now remember, you need to prise it off the bed. Do not split the 2 boards out or it will cause you issues. So prise it off the bed. We're going to flip it over right to left. lay it back down and fix it in the exact same position to run the same process again. So now we've flipped that over and stuck it back down, we're going to click return to 0. And all being well, it should be on the exact corner of the new spoil boards again. If for any reason it's slightly off, obviously you can reposition it. If it's something like 1/2 millimeter, you'll probably be okay because I have allowed some tolerance in this. But if it's anything more than 1 millimeter, then I definitely would look at repositioning it. Now, when you click return to 0, do make sure that the Z height is still correct, just in case anything has moved. It looks as though mine is touching the surface, so I think we're good to go. So let's run that same program again. So all being well, your holes will go all the way through like these. If you have one with a bit of material left in, like this one, you can just clean it up with a sharp knife when we separate the boards. So at this point, those two pieces of MDF that we fixed together extremely well, we now need to get them back apart, so we've got two separate spoil boards. I would suggest using something like a paint scraper to get in there and just prise them apart delicately. You don't want to put too much pressure on as you may distort the MDF, so be very careful when doing this. And then we can take one of those spoil boards, move back over to the machine and get it ready to mount. So we're about to stick this down for the last time, and you'll notice I've laid out the blue tape a little bit differently. Now what I suggest is when you come to lay the spoil board down for the final time, either make sure you put tape all over, if not at least make sure you cover all of the corners. Over time, if it's going to lift anyway, it will be on the edges and the corners, so that's where we're focusing all the tape and glue. So now we've got the board stuck down, we'll move on to surfacing it shortly, but before we do so we need to get an idea of just how level the bed is. So what we're going to do is we've lowered this down until it just about touches the top of the material. We're then going to go over to UGS, click reset 0, and that will mean that that is at 0, 0, 0. We're then going to move it 300 millimeters over here, lower it down slightly until it touches the top of that, and it will give us an idea of just how much it's out. We'll then do the same in the back two corners, and it will give us an idea if anything is leaning. So we know that's touching the top of the material, so we're going to click reset 0, and as you can see all the figures down here have now set to 0. So we'll lift this up by 2 millimeters, send it over to the right hand side by 300 millimeters. And then I'm just going to reduce the step rate down to 0.1 millimeters and lower it down slowly until it touches the top of the material. So that's now just touching the top of the material, and we can see down here in the bottom left hand corner it is saying minus 0.1, and what that essentially means is this bottom right hand corner is 0.1 millimeters lower than the left hand side. So we're going to lift that back up now. And then we're going to send it all the way to the back. And do exactly the same again. And that's just touching the surface again. So what we can see is this back corner is minus 0.4 millimeters. So essentially this is 0.4 millimeters lower than this front left hand corner. We'll move it over to the left hand side now and do exactly the same again. And again that's just touching, and that is at minus 0.2 millimeters. So we've got a bit of a slope going back to this right hand corner. Now you want to aim for anything within 0.5 millimeter. You can be a little bit more than 0.5 millimeter, but when we come to do the surface pass it just means you'll have to run it multiple times in order to take a top layer off everything. Now if it is more than 0.5 millimeter and you want to level things up, what I would suggest doing is releasing the bolts that are holding the bed down on the front and back and adding some sort of shim in just to lift up the corner or the side that you need to adjust until you get that to within 0.5 millimeter of being level. But as the lowest point on my bed is 0.4 millimeters, which is this back right hand corner, I'm happy with that. So we're going to bring it back to the front, get the surfacing bit in and start to surface it. So we've got the spoil board stuck down. Now I'm just going to pause the video a second and just give a bit of a health warning. Although we're machining MDF already, we were taking bigger chunks of MDF out. The next phase that we're about to do is surface the spoil board, which is literally where we skim it and take a thin layer off to ensure everything is parallel with our x-axis. Now whenever you're machining MDF anyway, you should have some sort of dust extraction, but particularly this step that we're about to do, because it will create a lot of fine dust. So make sure you have dust extraction or an enclosure, or at least a well ventilated area. If you are stuck indoors and you don't really have any of those options, make sure you have some sort of dust mask or respirator on, as I say, just to stop it sticking to your lungs, because it can give you a little bit of a cough or something at the end of the day. So let's move on and carry on, get this surfaced. So we've returned the machine back to 0. Now we need to swap out the collet insert. I've taken the 1/8 bit out, and we've now got to put the quarter insert in to replace the 1/8 bit. Now these can be a bit fiddly to get out. You can try pushing them from underneath and wobbling them either side to try and get them out, but sometimes it's just easier to use the insert you're about to replace it with. Place it over the top, put a bit of pressure on it, and it pops out nice and easy. So now we'll insert the 1/4 inch insert, put that back in, and then we're going to put in the 20mm surfacing bit and slide that into the collet. As always, make sure your bits are fully inserted into the collet before tightening everything up. And now we can get on with surfacing the board. Top tip I should have said a few seconds ago is, when returning back to 0, leave the 1/8 bit in, as it will be easier to find the corner. Then swap it out for the bigger bit, because trying to align that with the corner can sometimes be a bit difficult. So we've got the surfacing bit installed, and we've just lowered it down to touch the top of the material. Now if you are having issues setting the Z height, one thing I can suggest is maybe moving it in diagonally about 40 or 50 millimeters and setting the Z height slightly inside of the board. Now with everything set and touching the board, we're going to click reset 0. We're then going to load in the surfacing program, so we'll come back up to open, and then we're going to select the surfacing G-code option. And as we can see from the visualization, this is just a repetitive pattern going left and right, taking a very thin layer off everything. Now if we look over to this right hand side, we can see 10.3 millimeters. I know 10 millimeters is the safety height, so what this actually means is it will be skimming 0.3 millimeters off per pass. Now as we already know from the quick test I just did, the back right hand corner is actually 0.4 millimeters lower, so there's a good chance we're going to have to run this surfacing pass twice. Now a top tip before we start is to take a pencil and literally scribble all over the board. So just put wavy lines everywhere. And what this will indicate is that as it's passing over, we know the job is finished when all the pencil marks have gone. If we're seeing pencil left anywhere, it means it hasn't gone deep enough and we'll need to do another pass. So with everything set, let's start this job off. So I actually stopped this about halfway through. Once it got to this set of holes about here, it wasn't taking any more of the pencil mark off, which was kind of expected because we know that it slopes away to the back. So what I've done now is brought it back to 0. I'm going to lower this down by another 0.3 millimeters. There we are. Reset the 0 and start it again. So I said it would generate a lot of dust, and it really did, but what we have now is a perfectly flat surface that is parallel with our x-axis gantry, and there's no pencil marks left, so we know it's taken a layer off the entire board. Now I'm not sure if the camera can pick this up, but there are some very faint lines going left to right, and this is what's known as tramming. Now the purpose of tramming is to get the spindle as perpendicular to the bed as possible. So let's get reset up and we'll go through that in a bit more detail to dial our spindle in even better. Now as we just mentioned, tramming is about checking how perpendicular the spindle is in relation to the bed, and we're checking this on multiple axes, front to back as well as left to right, and it can be out in any of those or even both directions. Now when you're using a small bit like a 1/8 bit, you won't really notice it because of how small the tip is, but when you're using something like a surfacing bit, obviously because the head is much bigger, it magnifies any angles that you may have in the spindle itself, and that's essentially what leaves these lines, is when it's not perfectly perpendicular, you'll start to get the little tramming lines appear. So how do we solve that? So what I've installed here is a tramming jig, and basically what this is, to say, is 3D printed with a little 1/8 bit in the end of it. Now I did say at the start of the video, if you don't have a 3D printer, there's no need to worry. this is how we can do it using tools that we may already have to hand. This is just simply 2 Allen bolts zip tied together, and it does exactly the same job. You'll probably want a 6mm Allen key to go into the quarter collet insert, but as I say, it will do exactly the same job, and I'll show you how this works now. So much like the surfacing bit magnifies any angles in comparison to a 1/8 bit, this takes it even further, so it will show up any discrepancies when the spindle is rotating. So if I rotate this now, you won't hear anything, but if I lower this down slightly by a couple of clicks and now rotate it, I don't know if the microphone can just about pick that up, but basically this front quarter here it's catching. If I rotate it round, you can just hear that it stops about there, and then the other 3/4 of the circle it's absolutely fine, and it should catch as we come back in here. So what this means is the spindle is leaning slightly towards this bottom right hand corner. It's not a huge amount, but it is enough to mean that it's not perfect. So to get around this, we have a couple of options on how we can counteract this. You can shim the spindle itself within the holder, or you can adjust some of the bolts on the axis. So I'll zoom back out and show you what I'm going to do now to try and resolve this issue. So as we know this is leaning diagonally, I need to adjust it on 2 axes to counteract it and try and get it exactly perpendicular. Now the way we're going to do this is we're going to take a look at the X gantry first. There are 2 bolts on either side holding the gantry in place. We're going to slacken those off just very slightly, maybe like half a turn or something, and just see if we can tilt that back a little bit to counteract it. Once we've done that, we're then going to take a look at the spindle holder itself and try and counteract it the other way, as I say, just to get it perpendicular and stop it touching in that front right hand corner. So that stage can be quite fiddly, keep readjusting the bolts and trying to get this as level as possible, but the more time you spend doing it, the better the outcome will be, and ultimately we'll get better results at the end. Now, once you've done all the tinkering, you should have a nice even sound, so when we spin this round, as you can hear, it's touching nice and evenly all the way around. If I lift it up slightly, we shouldn't have any touching at all. Perfect. So we know this is now nice and level. Now, if your tram lines are quite prominent, as in if you run your fingers across your board and you can feel those tram lines, it might be worth at this stage going back and surfacing it again, and it should just get rid of all of those ridges. However, I can barely see mine, let alone feel them, so I'm pretty happy with that, and it doesn't need another surfacing pass. So the next step now is to put an alignment grid on, just to help us when positioning material going forward. Now I need to stress this is an alignment grid, do not really use it for measuring going forward. Although the lines should be spaced every 45mm, unless you've really calibrated and dialed your machine in, everything may not be precise. So yeah, as I say, it's an alignment grid, not a measurement grid. So let's get that engraved now. So for this final step, I've inserted the 20° V-bit. I've set it back on the corner of the material and just got it touching the top of the material as well, so we can easily reset the 0. So coming back over to UGS, the first thing we'll do is click Reset 0. We're then going to click the Open folder and come down to Grid and click Open. And we can see the grid lines now it's loaded, and what we can also see in this bottom right hand corner is 10.5. So similar to earlier, we know 10mm is the safe height travel, and it means it will be engraving at 0.5mm deep. So with everything ready, we'll click play and get this job done. So there we have it, we've machined a spoilboard. Well, in fact, we've machined 2 because we've got a spare one to use in the future. We've surfaced it, we've trammed the machine in, so everything should really be dialed in now to get nice, flat, even carves whenever we're doing any machining. Now, do remember that if you need to produce any spoilboards going forward, because we already have one in place, you can just do them one at a time as opposed to doubling up like we did today, so it just makes life easier now we've already got that spoilboard installed. that does wrap up everything today. As a reminder, do check the description area for links to files, links to bits that we've used, and any other useful information regarding the video. Big thank you to everyone for watching. If you enjoyed the video, please give it a thumbs up. Please subscribe to the channel. It really helps me keep everything going. And as always, a final thank you to my Patreon supporters. I appreciate every contribution that you give. Thank you very much for watching. I'll see everyone on the next episode.